Good day guys, I'm quickly just going to explain 4 things that I haven't covered in all the other videos for work energy power. The first thing is work done on a gas. Now you will find this in your textbook. If we go to your textbook, it's on page 74, and where it basically describes the work done in pushing a gas. So we have a gas cylinder, a syringe. It's got an area and there's a distance that you push the syringe. Okay, so what does that mean? If we know that work done is force times distance. Okay, but we know that pressure is force over area. So force is the pressure times the area. So the gas has a certain amount of pressure and we're going to apply it. So if we substitute in there pressure times area, okay, it's actually a small letter P if I think about it. Okay, so the work is the pressure times the area times the distance. Okay, and if we know that area times the distance forms another value, we get volume. Okay, so if we look at that graph again, okay, S is the distance, the area, so the area times the distance gives me the volume of gas that is being pushed or displaced. So therefore we've got volume, and pressure is equal to the work done on a gas. Okay, secondly, now where we get to power, guys, if you ever get a graph, remember power is work done over time or energy transferred over time. Whenever you get a graph that's work done over time, okay, or change in height over time, or change in kinetic energy over time, the gradient of that graph is the work done over the time, which is equal to the power. So when you're calculating the gradient there, you get the power. Sometimes they often don't use the word power, and you need to know the definition, and they speak about the amount of joules per second. So when they ask to calculate the amount of joules per second or the energy per second, that is the rate of energy transfer, which is the power. So they sometimes often not use the word power, but the definition, or they refer to the joules per second. Okay, so often what you will do is, the third thing I want to show you is they will use a electrical motor. Now in electricity, you remember the current times the voltage is the power. If you've done it in IGCSE, it's just current times voltage. If you haven't, we'll do it later this year. But whenever we want to calculate the electric power of a motor and they give us the current and the voltage, we use these two to calculate that. Most of the questions that I will be giving you guys will basically just be this simple calculation. It's not going to be in depth into circuits. It will just tell you that there is the power of a motor, or speak about a motor, and a motor is electrical, so it uses current and voltage, and you use that to calculate your power of your motor. The last thing, the fourth thing that we're looking at, is the efficiency. And the efficiency is always the useful output over the total battery input. Okay, so that can be the power out over the power in, or the work done out over the work done put in. Okay, so for example, if we get a question where we're pushing a force up the block, okay, so of a distance this much, the work done is the force times the distance, that is the input. The result of that work done, if it moves at a constant speed and doesn't accelerate, is that there is a change in the kinetic energy. Okay, so this is the output. Okay, so if we calculate the efficiency, we will calculate not the kinetic change in potential. So if we want to calculate the efficiency is the change in potential divided by the force times the distance. Now be very careful. Efficiency refers to the percentage efficiency, so you can give it as a percentage. All the parts in the textbook, they just ask for efficiency, but then they're referring to percentage efficiency. Anyway, I hope you have a good day, and that if you've got any questions, please let me know. Thanks.